Good morning, good afternoon, everybody. If you don't know me already, my name is Cam, and I work on the RAS team. Very happy to be working on the RAS team. We're going to talk about the new capabilities for HEC-RAS 7 as they pertain to results output and visualization. As RAS has become more capable, and we've added additional output capabilities to RAS, we noticed that access from that data from RAS Mapper had become a little bit not straightforward. So one thing we tried to focus on with this final version release was to organize access to the output in a very meaningful way that would be very straightforward. Anytime now you see in RAS Mapper the word mapping, that means your results are coming from RAS Mapper using the render mode that you've selected. So typically that's going to be a point time series where you click on a location and it's going to give you output. However, you can also get mapping results from other things like your bridges, your structures, and your reference lines, where it will go and sample the mapped water surface or mapped velocity off of that line. That information is being written out at the mapping output interval. The other title or item that we have on there are just results. So anytime you see results, that means it's coming from the computation engine and is being written out at the hydrograph output interval. So those are things like your stage and hydrograph output plots and stuff like that. So you can get more detailed information there for your flow and stage information that might not be synced up necessarily with your mapping results. And oftentimes that does cause confusion where somebody sees a value in the hydrograph output interval, but they don't see it in the mapping interval. And that's because we have two different output intervals. So make sure you keep your output intervals square with where you're expecting the data to go. And then realize when you're accessing it from RAS Mapper, results means the old hydrograph plot, mapping means your inundation maps using the render mode that's selected. So that's going to bring us to the hydrograph plot. As you've probably noticed, if you've been playing with all the beta versions that have been coming out, you've noticed that the hydrograph plot has slowly been morphing into what you see today. So each release, we tried to add a little bit new and make it a little bit better. And so here you can see the hydrograph plot now works where we have on the left side of the window, you're going to have a list or a table of the different node types. So the way that we were thinking folks are going to use this is they'll be looking at your node type first. So in this case, I've got reference lines selected, but this would be cross sections, 2D connections, etc. So you'll select the node type and then you'll have a list. And then that'll allow you to walk through the list as if you were going cross section to cross section, whether it be a 1D model, a 2D model, or a combined model. You can walk through each of those node types and then the plot will automatically update. And then what you'll also see in the new hydrograph plot or the revised hydrograph plot is that we have the plot types for each node available for you. So in this case, we're showing the profile plot. And so this is a cross-section profile. If we were looking at a river, for instance, then you'd see what we traditionally would call a profile plot. But you can see we've got profile plot, hydrograph plot, rating curve, hydraulic tables, and then if you have a breach for a structure, that'll be lit up and you can look at the breach plot. So here's just a little vision of what the hydrograph plot looks like for a bridge. You can see that you can walk through. This is a 2D model where I can walk through each of my different bridges, walking through and seeing what the headwater, tailwater looks like for that bridge, plotted against the bridge. Rating curve is really nice. Now we no longer need to open up multiple plots and stack them next to each other. Everything's all lined up. All the elevations are synced, so we can see, hey, are we getting a nice relationship between the water surface elevation and conveyance? And so we can quickly come out here and see, oh, we got a little hiccup in the giddy up right here. Maybe that's going on in the leftover bank. We can zoom in and figure out why we've got this little doubling back and make sure we have our curves smooth. So that's the rating curve plot shown with cross section. Super handy in my opinion. The hydraulic table plots, this is what we've been wanting to do for a really long time. We've now combined that for bridges. So if you have a bridge and you want to see what the bridge curves look like, you can see those. You can see the solution on top of the bridge curves. And so when your bridge starts to pressurize or when it starts to go unstable, you can figure out where that instability is going to be, zoom in there and figure it out, seeing both the plots side by side. Another thing that we've added is a bunch of different output. So we've been working fairly significantly on reference lines, trying to make them more and more usable and functional. And so here you can see a reference line that's being plotted, and you can see I can get two different plots. So here I've got average water surface plotted based on, it's a flow average water surface, that's shown in magenta there, compared with the water surface that's been mapped from RAS Mapper, in this case using the sloping method. And so you can see the two different answers that you could be getting. Why I think this is most important, if you're trying to evaluate your RAS model and you start to look in there and you're like, well, before my colleague got an answer that was 3,969.8, why is he getting that answer? Why am I getting 69.5? Well, where are they sampling the water surface from? Here you can clearly see if you're sampling the water surface in the main channel, you're going to get a lower answer than if you're sampling the water surface out in the overbanks. So not only does this show you the differences you might get between a 1D model and a 2D model, but it's also showing you the variance that you can get in a 2D model. And if you're trying to make an average estimate about something, you can see where those differences are going to arise from. When we're looking at these plots, we're trying to use the word mapped anytime it's coming from a RAS Mapper interpolated surface. Other than that, it'll be out of the computation engine. I don't know if you guys have noticed, but also our legend changed. So no longer, if we go back, we no longer have those checkboxes for turning things on and off. What we've done is we've implemented a hamburger button above the legend that'll allow you to get to the variables more quickly. So it'll clean up the plot for those reports you're doing, and it also gives you quick access to see everything that's available and turn things on and off very quickly. I think this is a great improvement that you're going to find very helpful. Hitting that hamburger button, it'll show you what's available. You no longer have to go to the options menu to find it. That being said, there are a few things hidden behind pop-up menus. So if you're looking for other things, right-click on the main interface, and that'll give you access to things like turning your bobber on and off, changing legend symbols, that type of thing. So hamburger button is going to give you most of what you need, but right-click on the plot itself to get to different plotting variables and options. We added a little checkbox to the plot so you can see what structure or reference line that you're actually working with. And so once you have that turned on, you can look in RAS Mapper and it will highlight in magenta what you're working on. And you'll also notice as you use the mouse to go over the water surface profile, in this case, it'll show you a little magenta dot on the line that shows you where you are. So here you can see the water surface that we're looking at right here in the interface is shown over in RAS Mapper as well. All those things that we're doing with the Hydrograph plot are really going to help you debug and improve your models. We didn't stop there though. We've actually been working on this for about 3 years behind the scenes, and that's where some of the stage and flow hydrograph niceties have come from, but we've been working on what Mark has termed the coordinated plot. And the coordinated plot is the hydrograph plot, everything you know and love about it, but we've also added the upper panel here that allows you to see a glimpse into RAS Mapper. So not only will that RAS Mapper inset allow you to see where you're looking, but you can also click on the node locations on the inset map and they will automatically plot down below. So here you can see this is a combined 1D, 2D model. I happen to be looking at bridges and culverts. This is on the American River. If I wanted to zoom in and click on another bridge, that bridge would pop up here. So you can access your information either through the tabular list that's on the left pane, or you can access it geospatially once you're within this coordinated plot. This is going to be helpful when you're working with just normal 1D models. With the coordinated plot, you can also turn on multiple plots, another key item. So here we're looking at the same bridge, but now I've added the hydrograph plot in there. So now I can scroll through time with my cursor and see what water surface and flow corresponds with what water surface in cross-section view, which I find to be super helpful. And you can keep turning things on. So you can turn on the rating curve. I skipped that. I turned on the bridge tables here. So now I can see the bridge solution. I can see for a given flow where that's going to enter into the bridge curves, what stage I'm going to get out of it, and where that's going to lay on my bridge. The coordinate plot gives you flexibility for not only accessing data geospatially and showing you geospatially where that data is, but turning on multiple plots at once, again, so you don't have to stack multiple plots side by side, which we were all doing beforehand. And so while that was great for 1D stuff, I think where this is going to be very beneficial, the geospatial access of data, is when it comes to our 2D models. When we're having trouble with our model, we're trying to debug into a particular 2D cell or set of cells, we'll be able to zoom into that location and then click on those faces and get face properties geospatially. That is obviously a far superior way than we were doing in the past, where you had to scroll through and find the cell of interest. If you know the cell of interest, you can go in and you can type in the cell or the face, and then we've got a button to zoom you into where that is, and then you'll be able to plot all the hydraulic properties. In this case, we're plotting the profile plot, so this is the face plot, and then all the hydraulic properties for that face. So I think the coordinated plot is going to give everybody much quicker access to modeling information, both for debugging and for evaluating results. As I mentioned earlier, we've been spending a lot of time trying to improve the output in RAS with reference lines, mostly for 2D output, but they can be used for 1D models as well. Here you can see I've got a 2D line, which I've tried to align with flow. So it's aligned with flow in the main channel, maybe not perfectly, and aligned in the overbanks. But one of the common questions I was always having, wanted to make sure that it was grabbing information from the correct 2D faces. Now, as we can look at this model, we might look, that 2D model wasn't set up very well. Maybe the guy that put that together should go back and he should fix that. And yeah, I probably should. But this was to demonstrate, yeah, all my faces are not aligned with flow, but what faces am I capturing in order to compute flow across those faces or velocity, et cetera. So we've added an option to reference lines where you can go in and turn on plotting of the faces that cross the line. And so those will get highlighted for you. And then you'll understand, okay, we're using this face. Let's pretend we're trying to accumulate flow. We're going to use this face, we're using this face, and so on. And so if you saw a line like this, you might say, okay, Ackerman did not do a very good job. Let's go in, let's do a little bit better job with generation of our mesh so that those faces align with that reference line. And make sure those faces align with flow so that we can get the best answer possible. We've been spending a lot of time with 2D bridges. We want people to be able to use big cells around bridges. And so here you can see I've added a bridge to my 2D modeling domain. I did not take the time to enforce my bridge. I just inserted it, and maybe I was zoomed out a little bit and I didn't get it aligned with the face very well. What we can see here is we've got our bridge shown in black, and then we have red lines, which are essentially, if we're thinking in 1D terms, cross-section 2, BD, BU, and cross-section 3. So we're trying to represent where we're going to extract information for the hydraulic bridge tables, for the bridge curves. And then when we go to compute losses across that bridge, we're computing them from the outside of one red line to the outside of another red line. And then we're putting those back into the 2D solution to make sure we have enough losses through the bridge. Well, sometimes when we have these big 2D cells, what we're ending up doing is we're saying the tail water for my bridge is in the same cell as my headwater for this bridge. And that causes a problem when we go to run the 2D solution, because the 2D solution says I shouldn't have any head loss across this cell. And yet when we go to look at the bridge solution, it's saying there should be head loss across the bridge. And so we get into a model unstable situation. And that model instability tends to end up giving us very poor results for our solution. So we've added a check in RAS. You'll get an error message now that says, hey, this structure is not aligned with the mesh faces, this bridge structure. The cells are found to be on the upstream side or also on the downstream side. So we'll give you a warning. We'll no longer run your model, and we'll go in and ask you to fix that. And if you want to try and see that happening before it happens, you can turn on these headwater tailwater sections. That's been available for a while, which we call those the 2D bridge sections, but we've added a new two new options to allow you to plot the bridge faces, the faces that the bridge thinks that are using in red, or plot the 2D cells. So here I'm plotting the cells, and so this is showing me that not only are the two main cells I'm expecting to see being used in the solution, but I'm also using these cells out in the overbank, which probably shouldn't have anything to do with the bridge. So maybe I need to go in and modify that bridge and fix those. So we're trying to help you troubleshoot that for the bridges. Speaking of troubleshooting, we've added a new troubleshooting tutorial for you for 2D modeling. We posted this maybe 3 months ago. And so if you haven't gone through this tutorial, you should. I think it's a very well done tutorial. It's going to walk you through the different computation level output and spatial maps that we produce and how you should be using them to both troubleshoot your model, improve your model, and get that model running faster. And so some of the things the 2D troubleshooting workshop are going to cover are looking at the overall volume accounting error, water surface errors and iterations, how you can generate spatial maps for both of those, and how to look at some of the debug output. We'll focus on max cell water surface error. We talk about hydraulic structures. We focus on culverts, but same sort of methodology can be used for hydraulic structures. We're trying to balance cell size around those with time step. It'll show you the importance of aligning cell faces with flow. You'll see you'll get a lot of iterations in a model that might be taking 10 minutes, and it should only take a couple minutes if you just improved your mesh with aligning with flow. We'll teach you how to use the find capability in RAS to find those cells that are iterating. Go to RAS Mapper, click on your geometry, hit Control F, type in your number, and you can get there right away. It focuses a little bit more on evaluating time step to improve and optimize your model at the end. And then we have this thing called Advanced Convergence. Advanced Convergence we released with version 6.6, but I don't know how many people are using it. This can dramatically improve your model. Sometimes you just get a couple cells that are just excessively iterating, and it really slows your model down. Okay, and then we're just going to finish up by reminding you, hey, if you're not using RAS 2025, now's the time to get in. Use it for creating your computational meshes. We have some really great tools that allow you to align your cell faces with flow. It'll allow you to do things that we just can't frankly do in version 6. So if you haven't played with it, download it and mess around with it a little bit. I think you'll find that the meshing tools have improved a great deal over the last year. And not only will they be fun, it'll be kind of exciting because you can do some things you couldn't do in the past. And if you want to learn more about that, we've got several workshops and tutorials on doing that. If you just hit our tutorials page for the HEC-RAS 2025 piece of software. And with that, I'm just going to say thanks for coming and spending your morning or afternoon with us. I want to remind you that Thursday, Stanford and Alex Sanchez will be giving you guys a discussion on bridge scour tool and secondary flow. And then I'm sure Alex Kennedy will be leading the Wednesday HEC-RAS 2025 update, where you guys can harass him all you want about the new meshing capability after you played with it. Bye, everybody. Have a great day.